Hi everyone. We in this lecture we are going to talk about nested loops. In the previous lecture, we covered the for loop and the while loop. So again, the loop is when a statement or a block of statements is repeated either a certain number of times or as long as a given condition is true. And then when it's false, then the program should stop automatically. All right, so let's create a new file here. So I'm going to call it nested loops. Okay, all right, as usual, we create new item and I'm going to call it the same thing, nested loops. Okay, and as always, we always start with the following: include IO stream, and then using namespace std and of course the main function. Alright, so if you remember last time we learned how to create a simple loop, for example a for loop. So we're gonna make this loop go from 1 all the way to 5 and incrementing by 1, and it's going to print an asterisk or star. Okay, so this loop basically all what it does, it keeps doing the same thing, which is printing a star, okay, a certain number of times. So if I run the program, it's going to show 5 stars. Okay, if I want it, let's say 10 times, just to change 10, now it becomes 10 stars. Okay, all right. So let's change it back to 5. Now, what about if I want this 5 stars to be repeated 10 times, which means I want 5, 5, 5, 5, 10 times. So all what I need to do is copy this code I already have. So I'm going to cut it, and then I'm going to create another loop, okay, that will do this 10 times. So of course I need to change the variable. I'm going to put x equals 1, x less or equal than 10, x plus plus. Now the loop that we did earlier, I'm going to put it here, which means I want to do whatever it's inside 10 times. So which means I'm going to get 5, 5, 5, 5, 10 times. So that's exactly what we have. But let's say I don't want it to be in one line. I want every 5 stars to be in a separate line, which means every time I finish 5 stars right here, then I want the program to start new line. So the best way is to use end line. So this, every time you print 5, end of the line, and then another time 5 stars, end of the line, and so on. So this will look like the following. All right. Now, of course, you can change. If you don't want it 20 times, after 10 times, you want it 20 times, you just have to change the number to 20. So now we have the same 5 stars, but it's going to be repeated 20 times. So that's, as you can see, the concept of nested loop is not complicated. We have an inner loop and we have an outer loop. So before you can change your value to the outer loop, you need to make sure the first loop or the inner loop comes to an end. For example, here in our program, I'm not going to move x to x equals 2, that means the second line, until I am done printing 5 stars. So the inner loop has to come to an end before the outer loop goes to the next step. Okay, so let's have another example to show how the nested loop can be used. Okay, so let's say, for example, I have a sum. I want to calculate the sum. Okay, so I want to calculate, let's say here, let me use x and y. So I'm going to change I because x and y goes together. So I'm going to use this one as y. Okay, so I'm going to do sum plus equal y. What do you think I'm going to get when I print the sum? The sum is sum. So what do you think sum here? So let's go step by step. Let's trace it. So when x equals 1, y will go from 1 to 5, which means the sum will be added. So initially sum is 0, and I'm going to add 1 because y initially is 1, then 2, then 3, then 4, then 5. Let's put a small number, so this way we don't do it. So let's say here we have until 5, and this one until 3, just to make it easier. So when x equals 1, that means that's the first line, okay? The first one. So the sum will add 1, 2, 3, because y will change from 1 to 3. So which means the first, when x equals 1, the sum will add 1, 2, 3, that's 6. Now it's time to change x to x equals 2. And then I'm going to repeat the same thing, add 1, 2, 3. So basically I'm going to add plus 1, plus 2, plus 3, plus 1, plus 2, plus 3, 5 times. So every pass, okay, it's going to add 6 because plus 2, 1 plus 2 plus 3 is 6. So if I repeated that 5 times, that's 30. So let's find out. See here that this, okay, let me print. Oh, this one, sorry, here needs to be printed outside. That means once we are done with everything, so it should be here. The sum is sum. All right. So it should be outside both loops. So as you can see right here, the sum is 30. The sum is 30. Now what happened if I change y to x? That means I start adding x. So x equals 1, and it's going to stay 1 until y comes to an end. That means when x equals 1, y equals 1. X equals 1, y equals 2. X equals 1, y equals 3. Now it's time for x to change to 2, and then you start over. 2, 1, 2, 2, 2, 3. Okay, now it's time to go to 3. 3, 1, 3, 2, 3, 3. So the first time you're going to add x, which is value of 1, 3 times. So 1, 1, 1. That's 3. And then it's time to go to x equals 2. 2, 2, 2. So you add plus 1, plus 1, plus 1, plus 2, plus 2, plus 2, plus 3, plus 3, plus 3, plus 4, plus 4, plus 4, and then finally plus 5, plus 5, plus 5. So if I run the program, the sum, if I add all the x's, will be 45. Now let's use a practical example, like a real life example, kind of. So let's say I want to solve a problem. So let me delete that and then try to solve a problem that involves nested loops. You can see how we can use nested loop to solve real life problem. So let me create here a description of the program. So let's say here I'm going to put a comment that explains what I'm trying to do here. So let's say create a program that displays, for example, all the prime numbers. Okay, everybody knows what the prime number is. All the prime numbers from, let's say, 3 to 100, for example, to 100 or to 50. That's limited to 50. Okay, now let me explain in case. Okay, explain what the prime number is. A prime number is a number that is divisible only by 1 and itself. Okay, let's give an example. Example like 3. Okay, 3 is divisible by 1 and 3 only. That's a prime number. What about 4? No, because 4 is divisible by 1, by 2, and by 4. What about 6? No, 6 is divisible by 1, 2, 3, and 6. Okay, what about 7? 7 is, yes, is a prime number because 7 is divisible only by 1 and itself. So any number that is divisible by excuse me, by itself and 1, it is a prime number. Now we don't want to include the special cases like 1 and 2. So that's why I started from 3. Okay, so now what are we going to do? So here I need to start with the first loop because the first loop is going to go from 3 to 50 because I want to check every single number from, let me use x. So x equals 3 and I want to go all the way to 50 and then x plus plus, right? So from 3 to 50, I want to check every number of these 3, 4, 5, 6, 7, 8, 9, all the way to 50 if it's prime number. Now, how do I know if the prime number, if a given number is like any of these values are prime numbers? Which means I have to divide, let's say 3. So I'm going to divide 3 by 1, 3 by 2, 3 by 3, and then count how many numbers are, basically how many divisors the number has. So if I have more than 2, remember prime number is divisible by itself and 1, which means you should have only 2 divisors. If you have more than 2, definitely it's not a prime number. So that's why I'm going to add another loop, let's say y, that's going to start from 1 because I'm going to divide by 1, by 2, by 3, by 4 until I get to the number. So let's say number 3. So I'm going to divide from 1 all the way to 3. So I'm going to go all the way to the number itself, which is in this case x. But if you notice, I didn't use equal sign because, well, I can use the equal sign. I can include the number itself. And then I'm going to put y plus plus. So now I'm going to start dividing and then look at the remainder. So if you divide x, which is the number we are looking for, if you divide it by each of the numbers from 1 all the way to the number itself, if the remainder is 0, then it's a divisor. Okay, I want to count. I may need to use like a variable that's basically allow me to keep track of how many divisors we have for each number. So I'm going to say 0. So if x divided by j and the remainder is 0, that means I need to count that. So I'm going to put count plus plus. Okay, so let me go back. Let's say, for example, number 7. Let's say x is number 7. So y is going to go from 1 to 7. 7 divided by 1, is it divisible? Yes. Add it. 7 by 2, no. 7 by 3, no. By 4, by 5, by 6, by 7, yes. So now you keep counting. I counted only 2 times. When 7 is divisible by 1, and 7 divisible by 7 by itself. So count will be 2. And then here, I'm going to say, okay, after finishing all this calculation, and then I'm going to check if count is equal to 2. Because if it's equal to 2, that means there are only 2 divisors, 1 and the number itself. And in this case, it is a prime number. So I'm going to put here out. And I'm going to put that the number that we're looking for, which is x, is actually a prime number. Okay, let me go over the program. So this variable count basically counts how many divisors we have. So we are looking from 3 to 50. Every single number, we're going to see if it's prime number. So let's say number 3. I'm going to divide 3 by 1, 3 by 2, 3 by 3. Okay, we have only 2 divisors, 1 and 3. So it should be a prime number because we counted it twice. Now let's move to 4. 4 divided by 1, 4 divided by 2, 4 divided by 3, 4 divided by 4. That's 3. Count is 3. So it's not going to show prime number because count is 3, not 2. And then you keep doing the same thing all the way to 50. And then 50, we're going to go from y is going to go from 1 to 50. And then we're going to divide 50 by 1, 50 by 2, by 3, by 4, by all the way to 49, and then 50. Definitely we have more than 2. Because 50 is divisible by 1, by 2, by 50 itself, by 25, and the 5. So definitely it's not a prime. So this program should show only the prime numbers. But here, once we finish with the specific or given number, we should not forget to change count back to 0. Because if not, then we're gonna have a problem. We need to reset it to 0 so we can start over counting from 0. So this is important, okay? Don't forget that. So now let me run the program. Oh, it looks like we have an error here. Let me check. So we have x, okay, y. Oh, I put j. I should put y. Y, because the second loop, the inner loop is y. All right, let's run the program now. Oh, here we go. Let's check if there is any counter example. 3 definitely is a prime number. 5, 7, 11. As you can see, all of them are prime numbers. So the program is working. Now, before we end, let's add one more example. So I'm going to delete this and then have one more example. So let's say, for example, let me put the description here. So let's say I want to create a program that displays all perfect numbers. Okay, I will define what the perfect number is. All perfect number from, let's say, 2 to 1000, because there is only a few perfect numbers. So what is a perfect number? A perfect number is a number that is equal to the sum of its divisors. And then I'm going to give example. For example, 6 is an example, is a perfect number. Why? Because what are the divisors of 6? 1, 2, 3. So 6 is equal to 1 plus 2 plus 3. So these are divisors. There's no, of course, we should not include the number itself. So 1 plus 2 plus 3 is 6. That's equal to the number itself. So it's called a perfect number. We have only very few, like from 2 to 1000, we have only 3, and 6 is one of them. Okay, we're gonna find out what the other numbers are. All right. So now definitely we need the sum, right? So let's declare sum because we need to add them up, add the divisors. So now we want to check the numbers from 2 to 1000. That's the first loop. So I'm going to put here x equal 2 all the way to 1000, x plus plus. And then just like the program that we had earlier, so we are going to check from 1 because we want to divide every value of x by values of y, like from 1 until the number itself. Like for example, number 6. So we're going to divide 6 by 1, 6 by 2, 6 by 3, 6 by 4, 6 by 5. And see, every time you find a divisor, then you add it to the sum. So I'm going to put here y is less, but I'm not going to put equal. Why? Because I don't want to include the number itself, because of number 6 here, I did not include 6 in the calculation. So it's less than x, and then y plus plus. So if the number x is divisible by y, that means the remainder is 0. Like 6 divided by 1, the remainder is 0. Okay, add it to the sum. 6 divided by 2, yes, the remainder is 0. Add it to the sum. What about 3? Yes. 4? No. 5? No. And then we stop. So if it is the case, sum, we're going to add that number, which is y. Okay? So once we finish the inner loop, then we're going to check is the sum equal to the original number, which is x, like in this case, 6. If it is, then we're going to put a statement that x is a perfect number. We don't have to put else because there are a lot of imperfect numbers. So we just want to focus on the perfect number. And then just like in the earlier example, we need to make sure we reset sum to 0 so we can start over, start counting or start adding again from 0. Okay? So now let's run the program and see. Oh, yes, as I said, we have only three numbers, 6, 28, and 496. Now let's prove that 28, or at least 28, so 496 is a big number, but 28, let's prove that 28 is a perfect number. So what are the divisors of 28? So I'm going to put here 28 equal to, okay, we have 1 plus 2, that's a divisor, and then we have 4, the 4 times 7 is 28, and then we have 7, and then also we have 14, 14. So 14 plus 7, 21, plus 5, 25, plus 2, 27, plus 1, 28. Definitely is a perfect number. So as you can see, so this is another example of perfect number. Okay, I hope these examples help clarify and then make it easy to grasp this concept of nested loop. Thank you for watching.